All right, today we're going to start chapter 8. We're going to start right at the beginning there at section 8.1. So this is day 30. We're starting here on a Monday with a fresh chapter. And we're going to talk about something that you guys have heard about before, we've talked about before, is the Pythagorean Theorem. Something that you've been exposed to in Algebra 1. So hopefully it's not something that's intimidating to us. Maybe it's just a little bit of a flashback as we go through this. So we're going to talk about the Pythagorean triple. Okay. So theorem 8.1 is the Pythagorean theorem, which we are used to. It's a relationship between the legs and the hypotenuse of a right triangle. So the legs are the two sides of a triangle that meet at a vertex that's a right angle. The hypotenuse always will be the longest side, and it will be opposite the right angle. So if a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. Meaning, if I make a square out of this side, and that breaks up into a bunch of little squares, and then I make a square out of this side, and that is made up of a bunch of little squares. Where do all my red squares go? All the red and all the blue little squares will come together and be the perfect amount of squares needed to fill up the area of the square made from side C. So this is a C by C, this is a B by B, and this is an A by A square. And essentially that's how it works out. Do not count the squares in there. I kind of just sketched those in there quickly for a visual, but that's what Pythagoras had in mind, and that's the theorem that we have. It does not matter which one you call A or B. Okay, these can be interchanged. This has to be C though. So A squared plus B squared equals C squared. Now, a Pythagorean triple is a set of non-zero whole numbers A, B, and C that satisfy the Pythagorean theorem. And one of the most popular ones is a 3, 4, 5 triangle. 5 is the longest, so that has to be the hypotenuse. Now, to show that this is a right triangle, we can show that's 3 squared plus 4 squared equals 5 squared. So 9 plus 16 equals 25. And we can make different versions of that. We can go 6, 8, 10. We can go 60, 80, 100. So just multiples of that triple would make a right triangle. So what is the length of the hypotenuse of triangle ABC? Now, this is either A or B. This has to be whichever one you did not choose for the 20. So 20 squared plus 21 squared equals C squared. So that's 400 times or plus 441. Do not add those together first and then square them. Exponents before addition, that's just a silly mistake that's made sometimes. And then to get C by itself, we're going to square root both sides. So C equals, so the square root of 440 or 841 is 29. Now that's not always going to come out to be a nice whole number. But when it does, It's a Pythagorean triple. So a lot of teachers use Pythagorean triples whenever they make up questions on their test. If they don't want the answer to be a fraction, or I'm sorry, to be an irrational number, not a fraction. A fraction will be rational. If it did not come out to be a whole number, then we would be simplifying the radical. The lengths of a triangle have, the legs of a right triangle have lengths 10 and 24. What is the length of the hypotenuse? So 10 squared plus 24 squared equals c squared. So this is 100 plus 576. So c squared equals 676. Square root of both sides. C equals 26. What is the value of x? So now we're looking for a leg. Don't always assume that whatever is missing is going to get isolated on the other side of the equal sign. This is A, B, and C. So it's going to be x squared plus 8 squared equals 20 squared. Now I know in middle school you might have been taught or been kind of shown two versions of the Pythagorean theorem based on what is missing. I always just write it out as a squared plus b squared equals c squared, and then I just solve from there. So that's x squared plus 64 equals 400. 400, now we're going to subtract the 64. So that's x squared equals 336. Square root both sides. And x equals, now if we take the square root of 336, it's an irrational number. So we're going to simplify that. What can we split 336 into? I like to always try 4 and 16 first, since they're perfect squares. If you remember when we used to make factor trees back when you were younger, you would always maybe divide it by 2, and you keep chopping that number down by dividing it by 2. Well, 2 is not a perfect square. So now try 4. Remember, the bigger the perfect square, the less steps that you're going to have. So I tried 16 right there, and it happened to be the correct one. So the square root of 16 is 4, and 21 is going to stay because it's not a perfect square. And the only thing inside of it is a 3 and a 7, and those are prime, and we can't break that down any further. So there's no more perfect squares inside of 21. So I'm safe with leaving it like that. So watch how it says, leave it as a simplest radical form. The hypotenuse of a right triangle has a length of 12. One of the legs has a length of 6. What is the length of the other leg? So x squared plus 36 equals 144. We're going to subtract the 36 from both sides. 144 minus 36 is 108. Square root both sides. 108. See, I'm going to try and divide it by 4. That works. 4 and 27, in fact. So here's what I think whenever I do that. 4 is great to divide it by, but 27 still has a 9 inside of it, which means that since there's another perfect square inside of this 27, then I should have taken out a 9 and a 4 at the same time. So I should have divided 108 by 36 instead of 4. So I did it in 2 steps, but really I'm going to pretend like I did it in 1 step. And so now that's going to be 6 radical 3. Dog agility courses often contain a seesaw obstacle, as shown below. To the nearest inch, how far above the ground are the dog's paws when the seesaw is parallel to the ground? So we're just looking for this right here. So they gave us the hypotenuse, and they gave us one of the legs. So x squared, or question mark squared in this case, plus 26 squared equals 36 squared. That gives us 620. Square root both sides. Now this said to the nearest inch, so that's going to be 25. All right, Theorem 8.2, it's the converse of the Pythagorean Theorem. If the sum of the squares of the lengths of two sides of a triangle is equal to the square of the length of the third side, then the triangle is a right triangle. So basically it's saying, hey, if these three sides are respectful to the Pythagorean theorem, then it is a right triangle. So it's one of the ways to prove that these three side lengths make a right triangle. So we're just going to test it. We need to know that 85 is bigger than 84 and 13. So that means 85 is the hypotenuse. So 85 squared is 7,225. And the sum of the other two squares is the same thing. And we can explain that and just say yes, because the three side lengths respect the Pythagorean theorem relationship. (16 squared plus 48 squared equals 50 squared. 50 squared is 2,500. 16 squared plus 48 squared is 2,560. So we can see that those side lengths do not respect the relationship defined by the Pythagorean theorem. So no. And then basically Theorem 8.3 and 8.4 build off the idea that the answer is no. So what if they do not equal? Well, then we have an inequality that can occur. The square of the hypotenuse can be greater than, or the square of the hypotenuse can be less than. And when it's greater than, we have an obtuse triangle, meaning it's greater than 90 degrees. If it's less than, then it's an acute triangle. And really not much to go over there. So we have these three. We're going to just check it out one more time. So we have 6 squared plus 11 squared equals 14 squared. So that's 196. That's 121 plus 36. It's just 157. So the hypotenuse squared does not equal So 157 is less than 196. Now it's up to you how you like to see that written. If you want to see the hypotenuse always on the left, then write it like that from the beginning. Just make sure you understand which side represents which part of the triangle. Right now we're saying the sum of the two legs is smaller than the hypotenuse. So this is going to be obtuse. Here we have 7 squared plus 8 squared equals 9 squared. So we have 113 equals 81. So that does not equal. 113 is in fact greater than 81, meaning the sum of the legs squared is bigger than the hypotenuse squared. That means this is acute. And that's basically what we're going to look at for the relationship inside the right triangles. There's your homework there listed at the bottom. Make sure you guys complete the exit ticket. Tune into any virtual office hours. Make sure you're getting a hold of me. Also, make sure you guys are keeping an eye on that grade book. The Schoology grade book does get synced. I usually sync it on Fridays since I don't assign anything on Fridays. Just make sure of your daily percentage, your daily completion percentage. That changes every Friday. Some of you go from 100 down to a 99. Just keep an eye on it. I wouldn't be too concerned if it's bouncing between a 100 and 99. I'm really looking for those who are really improving it or those who are really dropping in that column. But make sure you're also looking at your second semester grade in Power School. And get in touch with me if you have any questions about how the grading is going to finalize here at the end of the school year. Okay?